Hello friends, welcome to my YouTube channel Basic Electrical. Today we have discussed about the problems related to the symmetrical components. So the questions are given on the screen. That is a line to ground voltage on high voltage side of a step up transformer R 100 kV, 33 kV and 38 kV on the phases are A, B, C respectively. So the voltage on the phase A is lead to the phase B by 100 degree and the lags by that is C by 176.5 degree. So we have to determine analytically the symmetrical components. So first we have to draw the phasor diagram. So here you can see that what happened in this question. First of all, that is you can see that in the question the voltage A, voltage of phase A, that is phase A is lead by the phase B by angle 100 degrees. So here you can see that the voltage A, phase A is lead by B by 100 degree. Okay, next is that you can see that that is lags by the phase C by 176.5 degree. So it is you can see that VC, it is lag by 176.5 degree. Okay, so this is the voltage angle 100 degrees is VA is lead, phase A is lead by phase B by 100 and lags by 176.5 degree. Okay, so here you can see that you can like that is VA is the reference, so VA is 100 angle 0. Okay, and the VB that is equal to here the voltage of phase B, that is you can see that here the voltage of phase B is 33, phase C is 38 and phase A is 100. So that's why I have written here VA is 100 degree and angle is 0, reference is 0, and the VB, so VB is 33 kV and the angle is whatever it is negative because it is lagging, so 100 degree, and VC is equal to 38 kilovolt is given, and the angle, what is angle is 176.5 degree. Okay, so this is the angle. Now we have to calculate the positive sequence component. So what is the positive sequence component for that? So the positive sequence components, okay, what is the positive sequence components? So here VA1 is equal to 1 upon 3 VA plus alpha VB plus alpha square VC. Okay, so we already know about in the previous lecture what is the value of alpha is. Basically alpha is 1 angle 120 degree and the alpha square is 1 angle minus 120 degree. Okay, so we have to know what is the value of VA1, that is positive sequence component. So 1 upon 3 and the VA is, you know that what is 100 angle 0 degree plus alpha, that is 100 angle 120 degree, and what is the VB 33. So here VB is 33 angle minus 100 degree. Okay, and the plus what is alpha square, that is 1 angle minus 120, and that is the value of VC is 38 angle minus 170, sorry 38 angle 176.5 degree. Okay, so this is the VA1. So here you can see that 1 upon 3 and that is 100 angle 0 plus 33, and you can separate, that is 120 minus 100, that is equal to angle is 20 degree plus 38, and here 176 and minus 120, that is 56.5 degree. Okay, so that's fine. Okay, that is VA1 is equal to 1 upon 3. When you can add all this or in you can write in the polar component, that is you can see that is 151.97 and plus J 42.97. Okay, so you can see that VA1 is equal to 50.65. You can calculate through the scientific calculator. Okay, so that is J 14.3 32. So that is about the positive sequence components. Now we have to come to the negative sequence. Okay, so what is the negative sequence is there? That is negative sequence components. So here in this case, that is VA2 is equal to 1 upon 3, and that is VA plus alpha square VB plus alpha VC. Okay, so VA2 is equal to 1 upon 3, that is what is the value of VA, that is 100 angle 0 plus alpha square 1 angle minus 120 degree, and the what is the VB, that is 33 angle minus 100 plus what is alpha, so 1 angle 120, and here BC is 38 angle 176.5 degree. Okay, so you can solve, then you can get it, that is VA2 is equal to 1 upon 3 100 angle 0, and here that is 33, when you can add it, that is minus 120, here you can see that minus 120 and minus 100, so that is equal to minus 220 plus that is 38, and angle you can see 296.5. okay, so VA2 is equal to 30.55 minus J 4.26. okay, so this is VA2. What is it? It is the negative sequence component. Okay, now we have to come to the zero sequence component. Okay, zero sequence component. So in this case, how you can calculate, that is VA0 is equal to 1 upon 3, that is VA plus VB plus VC. okay, so here VA0 is equal to 1 upon 3, that is what is value of VA is 100 angle 0 plus VB is 33 angle minus 100 plus VC is 38 angle 176.5. so here VA0 is equal to 1 upon 3, and you can add it, then what is the value is, so here 100 angle 33 minus 100, and here same, that is 38 176.5. okay, so the value of this is 18.79 10.06. so that is the value of zero sequence component. okay, so here in this question we have to that is determine and analyze the symmetrical component, that is positive, negative, zero sequence. So you can calculate the positive sequence component, that is VA1 here, and the negative sequence component VA2, and the zero sequence component VA0. so I hope you have to learn how to calculate this. The next question is that, okay, so here you can see that the line current in amperes, that is phase A, B, C respectively, are given in the, that is 500 plus J 150, 100 minus J 600, and minus 300 plus J 600 is given. okay, so refer to the same reference vector and find the symmetrical components of the current. okay, so here the same reference vector, there is no lead or lag, something question is not mentioned is there. So here simply we have to write, that is IA is given, IB is given, and IC is given. so what is IA? that is 500 plus J 150, and the IB is given, that is 100 minus J 600, and here that is IC is given minus 300 plus J 600. okay, so it is given in the question. Now we have to calculate the zero sequence component, the positive sequence component, and the negative sequence component of the current. okay, so here you can see that the zero sequence component, that is IA0 is equal to 1 upon 3, that is IA plus IB plus IC. Okay, so here 1 upon 3 and the IA value is given, that is 500 plus J 150, and IB is 100 minus J 600 plus IC IC is what is minus IC is here, in this case IC is minus 300 plus J 600. So here the value of this, when you calculate it, that is 100 plus J 50 amperes. Okay, that is the value of zero sequence current. Now we have to come to the, that is positive and negative. So positive, that is IA1 is equal to, that is 1 upon 3, and that is IA plus alpha IB plus alpha square IC. Okay, so here what is the value of alpha square? In the previous question you can see that the alpha is in the angle form, so we have to return, that is alpha is equal to, here in this case alpha is written, I have written 1 angle 120 degree, or you can see the alpha, the value is, when you convert it in the polar form to rectangular form, then you can see that how to calculate it. Then its value is minus 1 upon 2 plus J root 3 by 2. Now the alpha square is 1 angle minus 120 degree. So here alpha square is value, alpha square is minus half minus J root 3 by 2. Okay, so the substitute all these value, what is the value given, that is IA1 is equal to 1 upon 3. So here IA is 500 plus J 150 plus, that is alpha minus half plus J root 3 by 2 into IB is 100 minus J 600. Okay, and the plus, that is alpha square minus half minus J root 3 by 2 into that is value of IC is minus 300 plus J 600 is there. So here IA1 you can get it easily, that is 546.3 plus J 165.46 ampere. Okay, so this is the value of IA1. Now move to the next part, that is the negative sequence current, that is IA2 is equal to 1 upon 3, here IA plus alpha square IB plus alpha IC. Okay, so now substitute all these values, you can get IA2 is equal to 1 upon 3, IA is given, that is 500 plus J 150, and here alpha square minus half minus J root 3 by 2 into IB is 100 minus J 600 plus, what is the value of alpha is minus half plus J root 3 by 2, and that is the value of IC is minus 300 plus J 600 is there. Okay, so when you calculate it, that is 48.8 minus J 21.82 amperes. So that is value of the negative sequence current. So I hope that you have to learn how to calculate the positive sequence, negative sequence and zero sequence components currents, and in the form of when the same phase is there, but if the phase is varies from angle in the point of view, then you have to easily calculate how to calculate the positive, negative or zero sequence voltages and currents. So thank you very much. Please like and subscribe my channel, Basic Electricals.